Hello everyone, Miss Hanley here. Today we're going to talk about monomials, and we're going to lead that into simplifying polynomials. This is section 7.1 and 7.2 in your books. So your learning target for today, I can rewrite expressions involving rational exponents using the properties of exponents. And so the first thing that we need to talk about is a monomial. So a monomial is a number, variable, or the product of those two things. And if you recall, product, that's when two things are multiplied together. So your examples here, 34xy or 7a squared b. You can also have just 14, just a constant. That's what we would call a constant. Still considered a monomial. Or you could just have x, that's a monomial, or y, or a, or z. Any combination of those is going to give you a monomial, and we're going to put those together to create polynomials. If you think about the prefix mono, that just means one. And so when you are talking about a monomial, it's something that's only one term, so it's like one group. Then they have to be multiplied together. If you see a plus sign or a minus sign in between them, that's when it starts to become a polynomial. Alright, and then a few other terms here. When we're dealing with exponents, which is all of these monomials and polynomials have exponents, the number that you're raising to a power is called the base. So in this case, 5 would be our base. And then the small number up above is your exponent. So if you have 5 squared, and there are some shorthand terms, so 5 or anything to the second power is considered squared. And that's actually from the area formula. So if you multiply two sides of something to find the area of a square, or the area of a rectangle, it becomes that, if it's an area of a square, it's that number squared. So that's how we get the first piece. And if anything is raised to the third power, we call that cubed, okay? Sort of like it has 3 dimensions. And a lot of times when you're measuring things, you'll talk about feet squared or square foot. So that's when you're talking about not just one-dimensional length, but two-dimensional lengths. Or cubic feet would be volume, how tall something is, how much depth something has. But anyway, we're going to work on just dealing with the monomials right now. And so if you have 5 squared, that's the same as 5 times itself 2 times. So 5 times 5 would be the same as 5 squared, or just 5 times itself. So that would give us 25. A lot of people do this quickly and they will make the mistake of saying 5 squared is 10. Remember, it's not multiplication, it's a power. So it's that number times itself, and that number has to show up however many times the exponent is telling us to put it there. So let's look at some rules of exponents. When we are working with monomials, we want to be able to multiply them together. We call this product of powers. And so you see up above, they've given you a to the m times a to the n is equal to a to the m plus n. So this tells me if I multiply powers with the same base, so that means like 5 and 5, or y, then we have to add our exponents. Seems a little silly, but when you multiply, you add. And let's look at what happens with our first example. So we know 5 squared is 5 times 5. And then 5 to the 6th is 6 of those. 3, 4, 6. And all of that is multiplied together. Well, how many 5s do we have total? 1, 2, 3, 4, 5, 6, 7, 8. So we would get 5 to the 8th power. Well, that's the same as adding 2 plus 6. So whenever you're multiplying powers, you end up adding your exponents. Alright, get that out of the way here. So if we have y to the fourth times y to the third times y, we want to add all of our exponents, and you can only do this if they have the same base. But if I look here, y to the fourth times y to the third, well, that would give me y to the seventh, and then times another y. Here, we want to know what the power is for just a y. And some people would automatically say, well, it's the 0th power. But if you raise something to the 0th power, you end up getting just 1. So actually, any variable or any number without an exponent written is raised to the first power. So here, if you do 4 plus 3 and get 7, and then you would have 7 plus 1, you would end up with y to the 8th. So no matter how many there are, you just keep combining. Alright, for our third example, we have numbers or coefficients outside of the variables. Remember that word coefficients, a very important word. When you are multiplying this whole expression here, you first need to multiply the numbers, so 7 times 6 gives me 42. And then you want to combine your powers, so we have y to the 5th times y, and remember that's really y to the 1st, so total that gives me y to the 6th. So 42y to the 6th is what that would simplify to. We can do the same thing in the following example, but this time they're getting a little trickier because we have an x and a y. You can only combine variables that have the same base. Alright, so when I am looking at this, I first want to multiply my numbers, negative 15. Next I'm going to